Hello, my dear students. Today we are going to continue our discussion on qualitative analysis. We are going to discuss the basic radicals and their identification. So let us start. Detection of cations, which are called basic radicals. We have given reason in this title. Identification of basic radical is more complicated than that of acidic radicals. The answer is that because there are large number of basic radicals and each cation has different oxidation states. Now, my dear students, the identification of cations is divided into 6 groups called analytical groups. Each analytical group has its reagent depending on the solubility of the metal salt in water. So, the scientific base for identification of cations is forming colored insoluble salt for the detected metal. The first analytical group. The group reagent here is dilute hydrochloric acid, and the precipitated salt here will be chloride salt. So the studied cations of this group are mercury Hg positive 1, silver Eg positive 1, and lead 2, lead Bp positive 2. The second analytical group. The group reagent is hydrogen sulfide gas in the presence of dilute hydrochloric acid. It is added to make acidic medium in the reaction. And the precipitated here, it will be sulfide salt. And the studied cations of this group, one of the cations that we are going to study is copper 2, Cu positive 2. The test for copper 2 ion. The salt solution plus hydrogen sulfide gas in the presence of dilute hydrochloric acid, the black precipitate of copper 2 sulfide is formed that is soluble in hot nitric acid. Here the equation proceeds on the screen. Copper sulfate solution plus hydrogen sulfide gas, it gives sulfuric acid aqueous solution and copper sulfide black precipitate. The third analytical group. The group reagent here is ammonium hydroxide, which is the main test for this group. The precipitation here it will be metal hydroxide. The studied cations of this group: aluminium ion, aluminium positive 3, iron 2, Fe positive 2, and iron 3, Fe positive 3. Test for aluminium ion. The main test here is the salt solution plus ammonium hydroxide solution. The produced precipitate will be white gelatinous precipitate of aluminium hydroxide, which is formed and dissolved in dilute acids and caustic soda. As the equation proceeds on the screen, the aluminium salt here is aluminium sulfate. When it reacts with ammonium hydroxide solution, it gives ammonium sulfate and white precipitate of aluminium hydroxide. The confirmatory test here is a salt solution plus sodium hydroxide solution. Here the produced precipitate is white gelatinous precipitate of aluminum hydroxide, which dissolves in excess sodium hydroxide, giving sodium aluminate that is soluble in water. So the equation proceeds aluminum sulfate plus sodium hydroxide. It gives sodium sulfate and white precipitate of aluminum hydroxide. Then the aluminium hydroxide precipitate reacts with excess sodium hydroxide, forming soluble sodium metaaluminate. So my dear students, we can make question here, how to obtain sodium metaaluminate from aluminum sulfate. So you have to write these two equations. Now we are going to discuss animation about this test. Now, my dear student, we use aluminum chloride salt as a solution of aluminum ion cation, and we are going to add sodium hydroxide solution over it. If the reaction continue, it gives white precipitate of aluminum hydroxide. This white precipitate of aluminum hydroxide, if you add more of sodium hydroxide over it, it will react with the sodium hydroxide and giving sodium aluminate. So on adding sodium hydroxide to aluminum hydroxide, which is the white precipitate, the reaction continue giving sodium metaaluminate, which is soluble in water, so the solution becomes clear again. Now, my dear student, we are going to test for the second cation of the third analytical group, which is iron 2 ion or Fe positive 2. The main test is a salt solution plus ammonium hydroxide solution. The produced precipitate is white precipitate of iron 2 hydroxide. This white precipitate turns to white green precipitate when exposed to air, and it is soluble in acids. As the equation proceeds on the screen, iron 2 sulfate plus ammonium hydroxide, it gives ammonium sulfate and iron 2 hydroxide, which is white green precipitate. And the confirmatory test here, the salt solution plus sodium hydroxide solution, so it gives here white green precipitate of iron 2 hydroxide. As the equation proceeds on the screen, iron 2 sulfate plus sodium hydroxide, it gives sodium sulfate and white green precipitate of iron 2 hydroxide, as the following animation will show. Now, my dear students, if you add the sodium hydroxide solution to iron 2 salt solution, iron 2 chloride, it gives white green precipitate of iron 2 hydroxide. Now, my dear student, we are going to discuss the third cation for the third analytical group, which is iron 3 ion or Fe positive 3. Here the main test, the salt solution plus ammonium hydroxide solution. Here the reddish brown precipitate of iron 3 hydroxide is formed, which dissolves in acids. As the equation proceeds on the screen, iron 3 chloride reacts with ammonium hydroxide solution. It gives ammonium chloride aqueous solution and reddish brown precipitate of iron 3 hydroxide. And here the confirmatory test, the salt solution of iron 3 and added to it sodium hydroxide solution. Here the produced precipitate is reddish brown precipitate of iron 3 hydroxide. As the equation proceeds on the screen, iron 3 chloride FeCl3 aqueous solution, salt solution plus sodium hydroxide solution, it gives sodium chloride solution and reddish brown precipitate of iron 3 hydroxide, as the following animation will show. As shown, my dear student, on the screen, on adding sodium hydroxide to iron 3 salt solution as iron 3 chloride solution, a reddish brown precipitate of iron 3 hydroxide is formed. Now, my dear student, we are going to discuss the fifth analytical group. The group reagent for the fifth analytical group is ammonium carbonate. Here the precipitated salt here is metal carbonate. The studied cation of this group, which is one of the cations, will be calcium ion, Ca positive 2. Test for calcium ion. The main test here is the salt solution plus ammonium carbonate solution gives wide precipitate of calcium carbonate that dissolves in dilute hydrochloric acid and in water containing carbon dioxide gas. As the equation proceeds on the screen, calcium chloride plus ammonium carbonate solution, it gives ammonium chloride aqueous solution and wide precipitate of calcium carbonate as the following animation shows. If we add the ammonium carbonate solution to the salt solution of calcium, it gives wide precipitate of calcium carbonate. Now we are going to discuss the confirmatory test. Here the salt solution plus dilute sulfuric acid gives wide precipitate of calcium sulfate. As the equation proceeds on the screen, calcium chloride solution plus sulfuric acid, here it gives hydrogen chloric acid and calcium sulfate wide precipitate as the animation shows. Here the wide precipitate is formed of calcium carbonate. As shown on the screen here, the dilute sulfuric acid on calcium salt, it gives wide precipitate of calcium sulfate. Now we are going to discuss the dry test here. The volatile calcium ions in the benzene flame, it gives brick red flame. Now, my dear students, we are going to make some revision on chemical calculation. What do we mean by the mole? It is the amount of the matter that contains Avogadro's number, which is 6.02 times 10 to the power 23 molecules, or atoms, or ions, or formula units of the substance. For example, when aluminum ion gains 3 electrons to form aluminum metal, 3 moles of electrons are needed to reduce 1 mole of aluminum ion into 1 mole of aluminum atoms. What do we mean by the molar mass? It is the molecular mass of the substance expressed in grams. How can we find the molar mass of the molecules? For example, find the molar mass of oxygen where the atomic mass of oxygen equals 16. The answer: the molar mass of oxygen is 2 times 16, it gives 32 grams. Another example, find the molar mass of carbon dioxide where the atomic mass of carbon is 12 and the atomic mass of oxygen is 16. The answer here: the molar mass of carbon dioxide equals 1 times 12 plus 2 times 16 equal 44 grams. Now we are going to discuss the relation between mass and molar mass. Here, my dear student, in the following triangle, if you multiply the number of moles times the molar mass, you can get the mass of the substance. Here, the relation between the number of particles and Avogadro's number. As the triangle shows here, if we know the number of moles and multiply it by the Avogadro's number, 6.02 times 10 to the power 23, we can get the number of molecules. To get the number of atoms, we have to multiply number of molecules times atomicity. Here the atomicity, it means the number of atoms in the molecule. So the atomicity of nitrogen molecule N2 equal 2, ozone O3 equal 3, phosphorus in vapor state B4 equal 4, carbon dioxide equal 3 atoms. For example, calculate the mass of 12.04 times 10 to the power 23 molecules of nitrogen, where the atomic mass of nitrogen equal 14. Solution. Here, my dear student, we have the number of molecules divided 6.02 times 10 to the power 23 gives number of moles. Then multiply number of moles by the molar mass you are going to calculate, we can get the mass of the substance. Number of moles equals number of molecules over 6.02 times 10 to the power 23. Then 12.04 times 10 to the power 23 over 6.02 times 10 to the power 23, it gives 2 moles. Here the molar mass of nitrogen N2 equal 2 times 14 equal 28 gram. Then mass equal number of moles times the molar mass, so 2 times 28 gives 56 gram. Or we can solve this problem by ratio. As we know, the molar mass of nitrogen N2 equal 2 times 14 equal 28 gram. This is related to the molecules of 1 mole, which is 6.02 times 10 to the power 23 molecules. So x gram related to 12.04 times 10 to the power 23 molecules. So the mass equal 28 times 12.04 times 10 to the power 23 over 6.02 times 10 to the power 23. It gives 56 gram. Now we are going to discuss the molar volume or the molecular volume. It is the volume occupied by 1 mole of any gas at standard temperature and pressure, which we call STB, which equals 22.4 liter. Here the standard temperature and pressure STB means the atmospheric pressure equals 76 centimeter mercury or equal to 760 millimeter mercury, and the temperature equals 0 degrees Celsius or 0 plus 273 equals 273 degree Kelvin. Here for a gas at STB, standard temperature and pressure, the volume of gas can be calculated by multiplying its number of moles times 22.4 liter at standard temperature and pressure. For example, find the volume of 132 gram of carbon dioxide at standard temperature and pressure. Solution. Molar mass of carbon dioxide 12 plus 16 times 2 equal 44 gram of carbon dioxide gas related to 22.4 liter. So 132 gram of carbon dioxide related to x liter. So the x volume of carbon dioxide gas equal 132 times 22.4 over 44 equal 67.2 liters. Now we are going to discuss the relation between the density, volume and mass. As the triangle shown on the screen, the density, which is gram per liter, equal the mass in grams over the volume in liter. So the molecular volume and molecular mass relationship. The molecular mass of a gas occupies molecular volume, which equals 22.4 liter at standard temperature and pressure. Now, my dear students, we are going to discuss some questions. The first one, choose the correct answer. The salt solution plus sodium hydroxide solution produce reddish brown precipitate of what? Is it calcium, iron 2,3, aluminum, or iron 2? If you think about the answer, here's the answer, it will be iron 3. Next one. Salt solution plus sodium hydroxide solution produce white-green precipitate of what? Is it iron 2, aluminum, calcium, iron 3? If you think about it, yes, it will be iron 2. Next one. Salt solution plus dilute hydrochloric acid and hydrogen sulfide gas giving black precipitate of what? Is it calcium, iron 2, iron 3, copper? Yes, it will be copper. Next question. Salt solution plus sodium hydroxide solution produce white gelatinous precipitate of what? Is it calcium or iron 2 or iron 3 or aluminum? Yes, if you think about it, yes, it will be aluminum. Next one. Salt solution plus ammonium hydroxide solution produce reddish brown precipitate of what? Is it calcium, iron 3, aluminum, iron 2? If you think about it, yes, it will be iron 3. Next one. The salt solution plus ammonium hydroxide solution produce white-green precipitate of what? Is it iron 2, aluminum, calcium, iron 3? If you think about it, yes, it will be iron 2. Next one. Salt solution plus ammonium hydroxide solution produce white gelatinous precipitate of what? Is it calcium, iron 2, iron 3, aluminum? If you think about it, yes, it will be aluminum. Next one. Salt solution plus ammonium carbonate solution produce white precipitate. Is it copper, iron 2, iron 3, calcium? If you think about it, yes, it will be calcium. Next one. Salt solution plus dilute sulfuric acid produce white precipitate of what? Is it copper, iron 2, iron 3, calcium? If you think about it, yes, it will be calcium. Calcium gives what color in the dry test? Is it pale violet, yellow, blue, brick red? Yes, it will be brick red. Next type of question, my dear students. From the following experiments, deduce the salt name and its chemical formula without writing the chemical equation. On adding lead 2 acetate solution to the salt solution, a white precipitate is formed. And when adding ammonia solution to the salt solution, white gelatinous precipitate is formed. My dear students, we have two experiments here. We are going to test the acidic radical and the basic radical to get the salt. Here we find that the basic radical is aluminum, as the ammonia solution gives white gelatinous precipitate with it. And here the acidic radical here, which is a negative ion here, it will be sulfate. As its test with lead 2 acetate, it gives white precipitate. So the salt formed here is aluminum sulfate and has molecular formula Al2SO4 Next one. When adding silver nitrate solution to the salt solution, white precipitate is formed, which turns violet when exposed to light. And on adding ammonium carbonate solution to the salt, white precipitate is formed. My dear students, here we have two experiments. Each one tests a radical, one testing the acidic radical and the other testing the basic radical. Here adding ammonium carbonate solution is testing for basic radical, which is calcium, as it gives white precipitate of calcium carbonate. But the first one, which is testing the acidic radical here, which is chloride radical. As the chloride here, as the question wants, gives white precipitate with silver nitrate, turns violet in sunlight. So the salt here will be calcium chloride and its chemical formula CaCl2. Now, my dear student, we discuss another type of question which is give reason for. Hydrochloric acid is used to detect the anions carbonate anion, bicarbonate anion, sulfite anion, sulfide anion, thiosulfate anion, and nitrite anion. If you think about it, yes, the answer it will be because hydrochloric acid is more stable than the acids of these anions, so when it reacts with their salts, it releases their less stable acid in form of gas that can be detected by suitable test. Identification of basic radical is more complicated than that of acidic radicals. The answer is that because there are large number of basic radicals and each cation has different oxidation states. My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed today, and till we meet again, my best wishes for you.